In this video, I'll be discussing how to handle specific exceptions in Python. On my screen, I have the module except_specific.py, which I will run that module with the Run menu to demonstrate how this works. If you are going to attempt to do something in Python that might cause some kind of error, then you'll want to implement error handling by using try and except blocks. You also can use else and finally blocks. In this case, this function that's defined specific handler will accept parameters x and y, and as it first prints, it'll try to calculate what the x value is divided by the y value. Because this might cause problems, we can try to do this operation, and if there is a problem such as zero division error, arithmetic error, or type error that is a specific type of error, then we can capture those as an exception object. And even though we are handling the specific error, we can print out more details about that exception object. We could also do something about that z that was calculated. If you try to do a calculation and it raises an exception, that value will not normally be calculated. So you would need to assign a value for the variable that you were trying to calculate if you wanted that to be handled. In the case of an exception that was neither a zero division error, arithmetic error, or type error that was specific, you still can handle the parent of all exceptions, which is the base exception. And again, capture the exception object. And when you go to print out the error message, you should use the REPR function so that you can get detailed information about what actually was the cause of the exception. Now, you also can have a else block that will print no exception that occurred, or maybe just do what it's supposed to do when the calculation works correctly, and that is return the value z. Also, optionally, you could have a finally block that would execute no matter whether the function succeeded or it failed in the exception handling. Now, down in the main part of the program that executes when the program is running in the main namespace, as we've discussed many times, we can see where it goes to print, calling the specific handler with different parameters, and then actually goes to call the specific handler function with those values. So in the first group of different statements that would print out, if we were calculating 5 divided by 2, no exception would occur, and that would happen from that else block. The value z would be returned, and the finally block also would execute as it was successful. And then we actually, at that point, would see the print statement with the value that was returned by that function. In trying to calculate 2 divided by 0, in that case, if you were to use 2 for x and 0 for y, it would try to divide 2 by 0, which would cause the zero division error. And we can see that that first exception block handled the zero division error and was able to print out the message from the exception object. We still have the finally block execute as this was successful. Finally block always executes. Since z was assigned a value in the except block, calling our function did return none. You can also see calculating 2 divided by z as the final call was made to the specific handler. In this case, 2 divided by the string z would cause an error when we would try to do that, but it wouldn't be a zero division error, so it would bypass that except block. It wouldn't match the arithmetic error, so it'd bypass that except block, but it is a type error. So we see that it handled the type error from that print statement, and we assign the value none to the variable z. The finally block, of course, executes as it always does, and we see the final printout for this handling 2 and z as parameters ended up returning none as a value. Now, if we did not have type error as an exception that was defined, and I'm going to make a quick modification to do that. I'll save my changes and run this again. We would notice that the final block of statements that executed showed it was caught by the base exception. And from that exception object, if you use the REPR or representation function on that object, you would be able to see that that was a type error. So it's important when you're handling specific exceptions that the most specific exceptions are listed first, and this least specific exception, the base exception, would be your last except block. That way, the specific handler can match if it is appropriate. If you don't have one that is specific, you can at least have a more generic match, and then be able to know from the representation information what kind of error that is, and then modify your code to add in an except block for that type of error, and then the code for how you would handle that type of error. So now you see how to handle specific exceptions in Python and even let them fall through to the more generic or most generic base exception.